7.8, factoring polynomials completely. Okay, so we're going to look at factoring by grouping. And factoring by grouping is a method that is often going to work when we have a four-term polynomial like this. Got four terms here, okay? So with any factoring, you always want to check for common factors. So let's kind of walk through this example step by step. So first thing I do is look at all four terms and see, is there anything that goes into all four of these terms? Well, there's no numbers that go into 3, 4, 6, and 8. And the x's go into the first three terms, but the last term doesn't have an x. So there is no common factor here, okay? But if we take this group of four terms and split it into two groups like this, so I put a parentheses around the front two and a parentheses around the back two, now I can look at the groups. So this first group does have a common factor because they both have x's, right? So that means I could factor an x squared out of this group, and that's what's happened right there, okay? And then the second group, these are both even numbers, so you could factor a 2 out of these, okay? And now once you've factored out the x squared out of the first group and the 2 out of the second group, you might notice that you have 3x plus 4 in both places, okay? And that, you won't, factoring by grouping doesn't always work, but if you, the problems you're going to see mostly in this section, it will work. And you'll know it's working if you get the same factor in the front half and the back half like this, okay? So if you don't get the same factor, it might be a dead end and you might not be able to factor that polynomial, okay? But for a factorable one, you will get these matching pieces. And the next step is the one that I find throws people off the most. So now what we're going to do, since there's a 3x plus 4 as a factor in the front half and in the back half, we're going to factor out the 3x plus 4. So often I see that this trips people up because, hey, we had two 3x plus 4s and now there's one 3x plus 4. So how did that happen? Well, let's take a similar example off to the side here. Sorry about the bell there. Okay, let's say I had x squared times a plus 2a. Well, the a is a factor of both of those, so you could factor an a out of this. So I could take this and say this is equal to a times x squared plus 2, right? You can imagine distributing the a into this binomial, and that would put you back here, right? So this is the same idea. It's just instead of a, I've got the quantity 3x plus 4. So you can see the 3x plus 4 is in the position of the a, okay? And now this is factored. This is factored, and you know, you could test it out by foiling it. If you foiled it, that would put you back at this polynomial, okay? Sometimes at the end of this, you might end up with more factoring, so you always want to check your final answer and see, well, 3x plus 4, I can't factor anything out of that. Sometimes you might end up with a difference of squares or something. But we don't have that here. 2 is not a perfect square and it's not a difference. So this would be finished, okay? All right, so let's try it out with some more examples then, okay? All right, so I'm looking at this. I'm going to split this into two groups. So it's okay just to do this, okay? If you have a minus sign in the middle, that'll be a little different, but we'll get to that in a minute, okay? And then I'm looking at the two groups. And if there aren't things that you can, if like I didn't have a common factor in the front group or in the back group, you could rearrange the order of the terms to try to get it so you can factor things out. But here I can factor an x squared out of the front group. Okay, and then I'm thinking about distributing. X squared times something is 3x to the third. Well, that would be 3x. And x squared times something is negative x squared. That would be negative 1. And you can just to kind of make sure you did it right, imagine distributing the x squared back in. That would put you back there, right? Second group, 6x and 2. Well, those are both even, so I can factor out a 2. And that would leave me with 3x minus 1. And you can see, hey, I've got this same group. So I know I'm heading down the right path here. Okay, so I'm going to factor out 3x minus 1 out of the front and the back. So one way you can think about it, make a parentheses for what they have in common, which is the 3x minus 1. And then make a parentheses for the leftovers. The leftovers are the x squared plus 2. Okay? And then I want to check to make sure there's no more factoring I can do. Can't factor anything out of the first group. Can't factor anything out of the second group. So we are finished there. Okay. All right, let's try another here. So I can split this like this again. And let's see if we have common factors. Oh, I should have said, I should check everything from the beginning to see there's no common factors at the beginning. But with all four terms, there's no common factor. But when I get it in the groups, there are common factors. So first group, 2 and 4, so 2 goes into both of those. But also they both have x's, so I want to take out the maximum amount of x's. So they both have at least 2 x's, so I'm going to factor out 2x squared. Okay? And 2x squared times something is 2x to the third, that would be x. 2x squared times something is 4x squared, that would be 2. Okay? Second group, I can factor out a 3. And now let's see, 3 times something is 3x, 3 times something is 6. Okay, and now I can see I have these matching pieces. So I'm going to make a parentheses for what they have in common, the x plus 2. And I make a parentheses for the leftovers. So really what I'm doing is factoring out the quantity x plus 2 out of the front and back. Okay, and then I want to double check my answer, make sure there's no more factoring, and there isn't there. Okay. All right, let's try another. I'm going to split it like that. And now I can see I can factor things out of the front. So let's go ahead and try that. So x squared I could factor out, and I can also factor out a 2. So 2x squared is the biggest thing that I can factor out. And then this would 2x squared times something is 4x to the third. That would have to be 2x, right? And 2x squared times something is 6x squared. Okay, now the back group, there isn't anything that I can factor out there. But that's okay because I still have these matching pieces, so this is still going to work. And this is a little weird. So there's no number there, but you notice I left a little space because I can put a 1 there. And that's going to become important when I do the next step. So I'm going to make a parentheses for what they have in common. Okay, and then I'll make a parentheses for the leftovers. And the leftovers is not just 2x squared because I need that 1 as a placeholder. Okay, so if you tried to, a lot of times I'll see an answer that looks like this. But if you distributed 2x squared into this, it was not going to equal that. It would be a trinomial, right? So I need the 1 there that I added in front of that to make sure this is going to work. And now if you FOIL this, it will give you that original 4-term polynomial. So you could check your answer like that. Okay. All right, let's try another. So I'm splitting this into the 2 groups. I can factor out, let's see, 2x squared out of the first group. That would leave me with x plus 1. There's nothing I can factor out of the second group, but when that happens, let's put a little 1 there, okay? Because that's going to become part of the one of the binomials there, all right? And then I do have these matching pieces. So parentheses for what they have in common. I'm really factoring out x plus 1. And then a parentheses for the leftovers. And then I'm checking this. There's no more factoring I can do. So that is my answer. All right, let's try some more on the next page. So these ones are going to get a little trickier because often what people will do is they'll make 2 groups. They'll make a group like this and then have the minus sign and then another group like that. So they'll just put parentheses around this and a parentheses around that and leave the minus in the middle. And you don't want to do that, okay? You want to add your 2 groups together. So here's how I can achieve that if there's a minus sign in the middle here. So I'm going to make my first group just as I always would, like so. There's my first group. But then I would want to put a plus sign, and I'm going to pull the negative in with the 4x. So I'm going to think of this as negative 4x plus 2. So that's how you want to set it up, not like this, okay? All right, and then let's go through the steps here. So I'm going to look at that first group. Both parts have an x squared. So let's factor out x squared. And then x squared times something is 2x to the third. That would be 2x. X squared times something is negative x squared. That would be negative 1. Okay? Now with this second group, I could factor out just a 2 here, and that wouldn't be incorrect, but I wouldn't get the matching pieces that I want. Okay? So when this term at the beginning of the second binomial is negative, usually you're going to want to factor out the negative, okay? Because I want this second part to say 2x minus 1. If I just factor out a 2, it'll be negative 2x plus 1. So, yeah, I could factor out 2, but I could also factor out negative 2 is what I'm getting at, okay? So if that third term is negative, factor out the negative. And then I'm thinking negative 2 times something is negative 4x. That would be 2x. And negative 2 times something is 1. That would be negative 1. So yeah, if you factored out positive 2 instead, then these would be opposites of those. They wouldn't match up. So if that happens, that's okay, but hopefully you'd notice they're opposites, and then you could factor out the negative as well to get these to match up. Okay? So from here on out, it's kind of the same. I make a parentheses for what they have in common, parentheses for the leftovers, and I'm always checking to see if there's any more factoring. Sometimes you might get a difference of squares, but 2 is not a perfect square. So there's no more factoring. Or maybe if you missed a common factor at the beginning of the problem, you might see it at the end here. Okay. All right, so this next one, let's see. Does anything go into 6, 9, 4, and 6? No, nothing does. And that last term doesn't have an x. So no common factors for everything. So let's split this into our two groups. And since I've got that negative in the middle, I want to pull the negative with the 4x again. So that's going to be my setup, okay? So the first group, well, 3 goes into 6 and 9, and then x squared goes into both of those as well. So 3x squared we can factor out. 3x squared times 2x would be 6x to the third. 3x squared times 3 would be 9x squared. Okay, second group, you could just factor out a 2, but I want to factor out negative 2 since this is negative. Okay, so I'm going to factor out negative 2. Negative 2 times something is negative 4x. That would be 2x. Negative 2 times something is negative 6. That would be 3. Okay. Then I've got these matching pieces. So 2x plus 3 I'm factoring out. And then I've got 3x squared minus 2. Okay. I'm double checking these to see if there's any more factoring. But there isn't any here again. So that's my solution. Okay. All right. So next up, again, I've got a negative sign in the middle here. So I'm going to add my two groups together. There's the setup. Okay. Let's factor out, let's see, we can factor out x squared in the first group. That would leave me with 2x plus 1. And I want to factor out the negative, and that's really the only thing I can factor out here. So I'm going to factor out a negative 1. And that would leave me with 2x plus 1. So you could just put a negative and not the 1, but you want the 1 there kind of as a placeholder on the next step, okay? So I've got 2x plus 1, okay? And then the leftovers x squared minus 1, okay? Now, if this were a test, I think a lot of people would put this as their final answer, and they wouldn't get full credit because it's not completely factored. So I'm always like 2x plus 1. We can't do any factoring there, but we can here. This is actually a difference of squares because this is a perfect square and this is a perfect square, right? X times x equals x squared, and then 1 times 1 equals 1. And it's a difference because we have the minus sign. So you got to remember the pattern from that, which is in the previous section if you want to watch the video on that. So this is going to factor into x plus 1 times x minus 1. It's kind of built on the square root of both terms, and one of them separated by a plus, the other is separated by a minus. So now this is completely factored. Okay. All right, let's give this next one a shot. Here's my first group. I want to add my two groups together. Okay. I'm going to factor out an x squared out of the first group. Let's see, this would be 3x plus 1. And I want to factor out the negative So I'm going to factor out -1, think of it like that, out of the second group. Okay, got these matching pieces. So this is very similar to the previous example. Get the 3x plus 1, and then we have x squared minus 1, but we got a difference of squares there again, so we can factor a little further, right? Because those are both perfect squares. So the x squared minus 1 will factor into x plus 1 times x minus 1. Okay. All right, last example. So this one's a little interesting because you could start splitting it into the groups and then go through the example right from the beginning. But I'm noticing that I can factor out something right at the beginning. There is a common factor with all 4 of these because they're all even numbers. So I can factor out a 2 right now. Okay? And if you miss it, you could do it at the end of the problem. You would just have to factor out some common factors once you get to after the factoring by grouping. Okay? But I'm just going to take care of it now. So 2 times something is 4x to the third. That would be 2x to the third. And then we'd have 2x squared. I'm taking half of all these because I'm thinking 2 times something equals those. Okay, so that's what it looks like when we factored out the 2. Now I'm going to work on this part and do factoring by grouping with the 4-term polynomial in there still. Okay, so I'm going to just, since I have a plus sign in the middle, I'm just going to split it like this. Okay, still got my 2 out here. But then in this group here, I can factor out 2x squared. Okay, 2x squared times x would be 2x to the third, and 2x squared times 1 is 2x squared. Okay, on the second group, I can factor out a 3. And that's going to look like that. Okay, so now I'm doing my grouping in here. So I see I've got those in common. Still got the 2 out there. Don't throw that away. That's going to be part of our answer. It's a factor of the, it's going to be a factor. Okay, so then in here I've got x plus 1. And then I've got 2x squared plus 3. Okay, now I'm looking at both of these groups. This is not a difference of squares. There's no common factors anymore. So we're actually finished here. And you don't really need this second set of parentheses anymore. It wouldn't be wrong if you wrote it, but I'm just going to write it like this for my final answer. And there we go. That's completely factored. So if you missed the common factor at the beginning, then one of your terms might look like 2x squared plus 2 or something. But if you had 2x squared plus 2, you'd want to factor the 2 out at the end, right? Or if you had 4x squared plus 6, you'd factor the 2 out. But that is going to be the final answer no matter what route you took. Okay, that's it for the section, and I'll see you next time.